It's time for a little helper review of quiz 10, which asked for a chiral chlorobutane. And this one sort of has the hidden piece of the constitutional isomers of chlorobutane. So if you have 4 carbons in a row, that would give you a butane. And if there's a chloro group on there, it can either be on the carbon on the end, which would be carbon number 1, or the inside carbon, which is carbon number 2. So if you just went ahead and put a chlorine on the first carbon, then you'd quickly find out that there were no chiral carbons here, because every carbon has at least 2 hydrogens on it. So if something doesn't have 4 different groups on it, it wouldn't be chiral. So that's sort of the first thing that we know about that we should always think about, is in order to have a chiral molecule in this class, we will have to have a chiral carbon. And then we can have enantiomers and optical isomerism and all that stuff. So here we go with chlorine on the second carbon, so 2-chlorobutane. And now we can see the chlorine, the hydrogen, a methyl, and an ethyl are the 4 different groups. So ta-da, now we have a chiral chlorobutane, and then we're asked to draw the R isomer. So the Fischer projection is just a T, where the chiral carbon is then the center, and then we want to put the 4 things, the 4 different groups on the chiral carbon, such that we get the right configuration. The hydrogen we're going to want in back, and if you remember the Fischer projection, the top and bottom positions are facing away from us. So if we put the hydrogen in the top, then we're in the right perspective to place the other groups. Atomic number wise, chlorine is the highest priority because it's atomic number 17. Carbon is atomic number 6 in both cases, but in this carbon is only attached to hydrogens. This carbon is attached to another carbon. So that makes the ethyl group the second priority, and the methyl group third priority group. And of course the hydrogen, being atomic number 1, is, if there is one, always the 4th priority group, lowest priority and put in back. So now we can place the groups in order. I usually just put the chlorine in any old spot, and then if we want the R isomer, we've got to go clockwise with the ethyl group and then the methyl group. So here's the Fischer projection for a chiral chlorobutane. It's the R2 chlorobutane. And I know this little helper is coming after exam 3, but that's okay because this stuff will be on the final. And if you get a chance to review this, and you also get a chance to review the exam 3 answers, that'll put you in a good position to do well on the final. So happy studying and good luck.